All right, so I am going to explain what I want you to do today. And the first thing I want to give you is a little checklist of the things that I want you to take care of. First of all, the homework from last night were the 1, 2, and 1, 3 notes. Hold on to that paper. Then go on Google Classroom and view the 1, 4, and 1, 5 notes and this video and then the POGL. So you should have viewed the notes by now. And what I want to do is just kind of give you a little summary right here at the bottom because I'm pretty sure this part was not in your notes. So the things that you have to realize and the most important things for Hardy-Weinberg are that P is the frequency of the dominant allele. So that would be like a big H, little h. Okay, so the big H. Q is the frequency of the recessive allele. So if you need to solve for P or Q, it's the number of alleles. Now, for the equation, P squared is the frequency of the homozygous dominant. And the 2PQ is the frequency of the heterozygous. And Q squared is homozygous recessive. So dominant allele, let's just use H's like I started to. That's the frequency of H. This is the frequency of little h. This is the frequency of big H, big H. This is the frequency of big H, little h. And then this is the frequency of little h, little h. Okay, now let's do a sample problem, and this is in your notes. So the key thing to remember is that P plus Q always equals 1, all right? And then, of course, the formula 2PQ plus Q squared equals 1. Because that means like 100% of the population or the whole. So if you look at this question, it says in pea plants, the allele for purple flowers, so I'm going to put a big P for purple, is dominant to the allele for white flowers. And you use the same letter. I'm going to do a little p with a line so I can differentiate them. Okay. If 99% of the plants have purple flowers, determine the percentage, what percent of heterozygotes are in the population. Okay, so let's look at this. First of all, you have to remember that just because P, big P, is dominant does not mean 99% are big P, big P. These 99% purple will consist of big P, and big P, little p, right? And so we need to find the big P, little p, but you can't differentiate by just looking at this 99%. How many are big P, and how many are big P, little p. However, you do know that if 99% are purple, that means 1% are white. Okay? And we know the white ones are little p, little p. So we have Q squared, right? And when we do that, we are going to put that in a decimal percent, so 0.01 in this case. And that is Q squared. So to take the square root, it would be 0.1. So Q is equal to 0.1. Now, this is where the remembering the fact that P plus Q equals 1 is so important. And also remembering if they're asking you what they're asking for heterozygotes, that means big P, little p. So we have Q right now, which is the frequency of the allele little p, okay, in this population. We know that P plus Q equals 1, so P is going to equal 0.9. So 90% of the population has the alleles, or 90% of the alleles in the population are big P. So with that, we can go to the answering of our question. So we want to know the percent of heterozygotes. So we know that the frequency is equal to 2PQ. So 2 times 0.9 times 0.1 equals, of course I've got to do this on the calculator because I am not a whiz. And I end up with 0.18. So that means that the frequency of the heterozygotes is 0.18. And that is in decimal form and frequency, so the percent is 18%. And that is how you solve Hardy-Weinberg.